Hello everyone, my name is Alyssa. I'm a third year student of International Program of Artificial Intelligence I-Shou University. Now I'm gonna present to you my single chip controller final project, Teletubbies Gesture and Color Recognition System. The Teletubbies Gesture and Color Sensor project is an interactive system that combines gesture recognition and color detection to emulate the iconic characteristic of the Teletubbies characters. Tinky Winky, Dipsy, Laa-Laa, and Po. Each character is distinguished by unique antenna shapes and colors, which serve as the basis for this design. By integrating sensor-based inputs, real-time processing, and multimedia feedback, the project delivers a playful and educational experience. This system is designed to showcase the applications of embedded system in creating engaging interactive tools. Through the use of various sensors and actuators, users can interact with the system, making it an ideal demonstration of technology's potential in education and entertainment. Now, let me tell you the purpose of this project. First, to educate users. Provide an engaging introduction to the principles of embedded systems, including the use of gesture and color sensors, microcontrollers, and output devices. Second, to demonstrate technology integration. Illustrate how multiple sensor modalities can be combined to achieve a cohesive and interactive system. Third, to encourage creativity. Inspire users to explore the creative possibilities of sensor-based system by leveraging a familiar and entertaining theme. Fourth, to promote accessibility and interaction. Showcase the potential for gesture and color detection to be applied in accessibility tools, educational devices, and interactive gaming systems. Let's continue with the design flow. First, initial setup and Teletubbies theme song. Do you know the Teletubbies theme song? Tinky Winky, Dipsy, Laa-Laa. Oh, Teletubbies, Teletubbies, dum, dum, dum. So, the buzzer will play that song to initialize the system and engage users. This phase sets the stage for the interactive session. Second, gesture recognition. Users create specific gestures representing the Teletubbies antenna shapes. So as you can see, each Teletubbies have their own shapes of antenna. Like for Tinky Winky, it's gonna be like a triangle gesture. For Dipsy, vertical line gesture. Laa-Laa spiral gesture, and for Po, circle gesture. A gesture sensor or similar device processes these inputs, identifying the corresponding character. Next, color detection preparation. An OLED screen displays a countdown timer, allowing users time to prepare the color sensor. Upon timer completion, the user positions the sensor over an image of the selected Teletubby. Fourth, color detection and feedback. So, the color sensor reads the input and identifies the color of the image. The buzzer then plays a 1-second tone to confirm color detection. And last, validation and output. The OLED screen displays the recognized antenna gesture and detected color. If the gesture and the color match the same Teletubby, the system indicates a match, and then the servo motor rotates to signify success. But if they do not match, the system indicates a mismatch. So the servo motor will just remain stationary. Hi guys, now I'm gonna show you my single chip controller final project, Teletubbies Gesture and Color Recognition System. Initially, it plays the melody of Teletubbies theme song. Now it tells me to make a Teletubbies antenna. So as you can see, each Teletubbies have their own shapes of antennas and have their own different color. Now let me do the gesture for Tinky Winky. It knows that I'm making a gesture for Tinky Winky's antenna. I have a few seconds to prepare my color sensor. Yep, the antenna belongs to Tinky Winky, the color belongs to Tinky Winky, so they match. Because they match, the servomotor will rotate like this. Let's try it again and see what will happen if the antenna and the color don't match. This time, I'm gonna do the gesture for Dipsy's antenna. Yep, it's Dipsy. And let's try this color. It knows that the antenna belongs to Dipsy and the color belongs to Laa-Laa, so they don't match. That's why the servomotor won't rotate. That's it. Bye. Now let's continue with the method that I use for this final project. First, gesture data collection. Gesture data is collected using an MPU6050 sensor by sampling 6 parameters: accelerometer and gyroscope readings along 3 axes over defined periods. The data is captured in rounds with specific gesture for Tinky Winky, Dipsy, Laa-Laa, and Po, performed while pressing a button to trigger collection. Features are saved as multidimensional arrays for each gesture. And for the color data collection, using an APDS9960 sensor, ambient, red, green, and blue light intensities are collected to capture color features of objects representing Tinky Winky, Dipsy, Laa-Laa, and Po. Features are normalized to proportions and the data is saved for training. The next step is data pre-processing. First, we do the normalization. All collected features are normalized using mean and standard deviation for consistency and improved model performance. This is applied to both gesture and color data. And the second one is categorization. Labels for different gestures and colors are assigned as categorical values for supervised learning. Next, I did model training. For color recognition neural network, for the input, features from APDS9960 sensor, normalized RGB values. And then for the architecture, a feed-forward neural network with input layer with matching feature dimensions, 2 hidden layer, and the output layer with a softmax activation for multi-class classification. The model is trained using mean squared error as the loss function and the Adam optimizer. And then for the gesture recognition deep learning model, for the input, it's aggregated time series features, 10 periods times 6 parameters. And for the architecture, a similar deep learning model is implemented with adjustment for handling temporal data and increased complexity to accommodate gesture dynamics. And for the next method is model deployment. Trained models are exported and deployed for real-time predictions. Features are dynamically collected from the sensors, reprocessed, normalized, and passed to the model for classification. Predictions are displayed via serial output. Here are the tools and libraries used for the project. For the hardware, there are MPU6050 for the gesture, APDS9960 for the color sensor, and then buzzer. It produces audible alert, and OLED to display visual information, and servomotor. It drives mechanical motion. And for the software used, we use custom libraries like Flag MPU6050, Flag Data Reader, Flag Model, Flag Data Exporter. These are used for sensor interfacing, data handling, and neural network implementation. Now let me tell you the real-life application of this project. The Teletubbies Gesture and Color Sensor project demonstrates a novel integration of gesture and color recognition technologies. This approach is highly applicable in various real-world contexts, where interactive and adaptive systems are gaining prominence. Below are key application areas. First, we have health and rehabilitation. Gesture and motion recognition can be employed in physiotherapy to monitor and encourage specific exercises, while color detection can be useful in medication management by identifying color-coded pills or packaging. Second, education and learning tools. Gesture and color recognition systems can be incorporated into educational platforms to create engaging learning experience for children. For example, interactive storytelling and shape matching games can help develop cognitive and motor skills in early learners. Third, interactive gaming. Games that involve physical gestures and real-time feedback are more immersive and enjoyable. Technology can be adapted to enhance virtual reality (VR) and augmented reality (AR) experiences, allowing players to control game elements through natural motions and real-world interactions. Fourth, retail and shopping. Gesture recognition can improve customer interaction with digital display and kiosks, while color detection can assist in identifying products or scanning barcodes efficiently in retail environments. Last, robotics and automation. Robots equipped with gesture and color sensors can interact intelligently with humans, such as in customer service role or collaborative industrial tasks. They can also identify objects and execute commands based on detected attributes. To conclude, the Teletubbies Gesture and Color Sensor project successfully demonstrates the integration of gesture recognition and color detection within an embedded system. By utilizing the iconic Teletubbies characters, the project offers a unique and engaging approach to exploring sensor-based interaction. Through systematic process of data collection, preprocessing, model training, and real-time deployment, the system achieves accurate and responsive functionality. This work not only highlights the creative potential of embedded systems, but also underscores their applicability in educational tools, accessibility solutions, and interactive entertainment. Future extension could include additional sensors, advanced machine learning models, or expanded applications, further solidifying the project's value as a versatile and inspiring technological demonstration. That's all for my project. Thank you all for listening and goodbye.